Hello, Ed Wicklein with Corollo Engineers. We're going to talk a little bit more about model setup for the technical guidance manual computational fluid dynamic modeling of contact basins. We've gone through a number of modules and realized that we needed to set up a module 5B with some additional simulation information for the follow-up for the next steps after we have mesh dependence. So we need to run our flow conditions to convergence and then simulate the tracing. We've set up our model. We've run it to flow convergence for one of our cases. And on our spreadsheet for the different cases we need to do, we would also have the second one, the 50 percentile flow. We would run the hydraulics for that as well. So within Fluent, once we've run that, we are going to set up our transport model. In this case, we look at the species transport model. We've got a couple of fluids here. H2O new would be our tracer. We set up the model using the frozen fluid approximation. And so under the boundary conditions at the inlet for a lug dose, or step dose, we would set the fraction to 1, so 100% of the flow coming in is our tracer. We've converted our model to a transient model, so it's going to have a time marching component. We turn off the flow and the turbulence equation, so we're holding those values steady while our tracer is being released and dispersing through the tank in time. We need to set up monitors. So we will have a report file that tracks key data. So we want to track particularly the tracer at the outlet. That's how we're going to generate our curve. And we need to determine how long we're going to run this simulation for. So on our spreadsheet, we work this out. Hydraulic resonance time is 60 minutes for the high flow we're simulating and 108 minutes for the low flow. Based on past experience, computer resources, other features, we'll pick a time step that's reasonable for our mesh to track the data. We're going to want to have an output frequency where we write files. We don't want to make too many files. We'd like to write around 10 output files along the way so we can create animations if necessary. And so we've picked a 5-second time step, 10-minute output. That would be a 600 second frequency. We simulate 120 seconds. That gets us to a little over 1 resonance time. And so we've got this output file we're going to be writing, and then we also can write the output file here at some frequency. So we've picked 120, every 120 time steps. Then we'd run the calculation. We set it up to 5-second time steps, sufficient number of time steps to get the hydraulic resonance time we want. And then we hit calculate, it runs the simulation, and it takes several hours to generate the output files. From that, we will be able to use the output data and move on to our final step, data processing. Thank you. If you guys have any questions, you can email them to me, or we'll be able to discuss it further in the live session when we put that together. Thank you.